All right, so today, class, we are doing our lesson right before learning how to use protractors. And one way we can measure angles is with our pattern blocks. So on this page here, you can see that we have some pattern blocks that we are used to, that we've seen before. And we're just gonna use these to help us identify angles and measurements of angles and things like that. So first one I'm gonna look at here is this square. The square, of course, its attributes, it has 4 right angles. Remember from last week that our right angles are worth 90 degrees. So if I should take this shape and drag it over into one of these angle measurements here, I should be able to find a 90-degree angle. And you guessed it, it's this one right here. Fits the angle of this square fits directly inside the angle of that measurement. And so we would classify that angle measurement using this square. This would also be a 90-degree angle. And it can be classified as a right angle. We're going to move on to this rhombus over here in the right-hand corner. Now, it doesn't have it 90-degree angles because there's no 90-degree angles in it. What it does have, it has two obtuse angles. Remember, obtuse meaning greater than 90 degrees. And it also has 2 acute angles. Now, if you look closely, those acute angles are the circles or the semicircles that we are using are smaller than the larger obtuse angles. That means the angle measurement is going to be smaller. These angle measurements are actually, these acute angle measurements are actually 60 degrees. And these obtuse angle measurements over here are going to be 120 degrees. Now, if you added all of these angles up, 60 and 60 is 120, and then 120 and 120 is 240. So this whole shape here is worth 360 degrees, just like this square is 360 degrees. I can only imagine that these 2 last shapes that we need to measure are also going to be equal to 360 degrees. So it's going to be the same measurements of these different types of quadrilaterals. They're going to be 360 degrees in total. So if this one here has 2 acute and 2 obtuse, you can use these angle measurements to see which ones these fit in. That one looks like it's a perfect fit for this. So using that acute angle there, we can measure this angle being 60 degrees as an acute because it fits in from our pattern block. Our pattern block fits directly in there, and if we know that angle is 60 degrees, that is what this angle measurement is going to be. And let's see here. We are going to next move on to the other rhombus. Now you notice with this rhombus it's a lot smaller, and you can tell that the angles are a lot they're more acute and more obtuse in this. So if you take a look at this angle right here and this angle right here and compare it to these, those openings up here are a little bit larger than these openings. So it has to be less than 60 degrees. These actually measure 30 degrees. Both of these angles here, 1 and 2, both acute angles measure 30 degrees in this small rhombus. And that these 2 obtuse angles here are larger and more bent back, leaning back than these 120. So these have to be actually 150. 30 degrees more for our obtuse and 30 degrees less than our acute from our previous rhombus. So again, 150 and 150 is going to be equal to 300, and then 30 plus 30 is going to be equal to 60. So 300 plus 60 again is equal to 360 degrees. So it works out for that one too. So let's try to drag this one over to see if this one fits in any of the ones that we see. And I see this one should be pretty close. Yep, it's right there. So that angle measurement is going to be 30 degrees. It being obtuse again because it's leaning forward. It's less than 90, acute because it's leaning forward. And we're going to drag this shape back. And then we have one more different shape. This is a trapezoid. And one thing that separates a trapezoid from all other quadrilaterals, it only has one set of parallel sides. These both are parallel. These that are going up the sides are not, because they will eventually intersect each other or cross. So this one is going to look very similar. These acute angles will look very similar to this rhombus here. It should match up pretty closely, and I believe it does. So this acute angle here in this trapezoid has to be the same exact measurement of the acute angle in the rhombus or parallelogram. And then if both of these acute angles here are 60 degrees, that has to leave these two acute obtuse angles at being both 120. So the angle measurements for these trapezoids and for this specific rhombus have exactly the same angle measurements. This is also equal to 360 degrees. And if we use this and bring it over, we can see that that angle measurement is also 60 degrees. This acute angle is going to be 60 degrees. And then we have one more angle measurement. It looks obtuse, because I know that because it's greater than 90 degrees. It's leaning back. So I'm going to find any obtuse angle that I find, and I'm going to see if I can create it in there. This one, a lot greater than 120. That's going to be 150. So maybe I can use a 120 degree angle, and it fits perfectly in there. So I'm going to go ahead and measure this one as 120 degrees. One of our benchmark obtuse angles, one that we commonly find in a lot of our shapes. So remember, right angles, 90 degrees, can use the square pattern block. Acute angles, such as these three here, 1, 2, 3, can all be used with pattern blocks with the different rhombuses, and could also be used for the trapezoid for the acute angles. And the obtuse angles, you're going to want to use the opposite angles for your rhombus or rhombi and trapezoid as well. So I hope this helps. Remember to use those pattern blocks that was attached to the assignment. And good luck. Bye.